Hey everyone, welcome to day 4 of Keysight University Live. Today is March 18th, which means we have a bunch more test gear that we're giving away, and we have an interview with an expert. Today is all about 5G. Earlier on the YouTube channel and lower on this page, we have a 5G video that covers some of the cool 5G engineering tricks that go into making 5G actually work. We put this video together because we found out it was really hard to actually learn how 5G works. So this was an opportunity to not go super deep, like white paper spec sheet deep, but also a little deeper than some of the fluffier content that's out there for those of you who, not you watching the stream, but for those folks who aren't engineers, we like to dig in a little deeper. So we have a video for that. Actually, let's take a look at the web page just so we can make sure we're all looking at the same thing. So at the top of each day's page, we have a specific page for each day, and you can see that reflected in the URL. Let me find my mouse here. And so we can see we're on day 4 here. At the top, we have the live stream, which is happening now. I am not playing it for obvious reasons, because who knows what internet would break if I live stream by live stream. We have chat windows, so if you're here at 10 a.m. Mountain Time, you can chat with us. We have people from Keysight here on the team who are helping moderate that chat. And we'll do some Q&A at the end of the stream as well. So if you put your questions in chat now, the team will send them to me throughout the course of the day. We have a brief description and maybe some URLs. If there are URLs I call out in the stream, we'll put these here. And then at the bottom of the page, we have another embedded video. There's a couple winners announced at the end of this video. We also put winners, all of the winners, in the live stream, so you can just stick it out through the live stream, and we'll do the winner announcements right after the interview. Additionally, on this page, there are 2 buttons here. We got some feedback on the buttons. We're working on those, but there's a Get My Daily Entry button, and you can click on that one, and that gets you an extra entry in for the drawing. Every entry that you have is eligible for every drawing, so you don't have to be here to be eligible for the drawings. It just increases your chances of winning. And then there's a Keep Me Updated button. This is a way for us to contact you after this event. We have some special things planned that are just for folks who attended this event and are joined in with us. So make sure you click that button so you can get these updates. Otherwise, I think we can't email you at all, and you'll miss out on the stuff we have planned. We have some really cool things, some swag and some freebies and stuff. So make sure to click that button. At the very bottom of the page, we feature a Keysight University course. Today we're featuring a learning path all about 5G. So if the interview that's coming up in the stream in a little bit is not enough for you, and this video at the bottom of the page is not enough for you, make sure to go check out these courses. We have a bunch of free courses about 5G. I helped write and create a lot of these 5G courses, so if you want to learn more and get more depth than we covered today, this is a great opportunity for you to learn more about how 5G works. And of course, we have a SmartBench Essentials Challenge going as well. So if you don't want to leave your test gear winnings up to chance, you can go join the SmartBench Essentials Challenge. We got a little bit of feedback that it was hard to tell if you'd actually gotten your entry in or not. So we've tweaked that experience a little bit so it's more clear now. If you've entered, you will see some more confirmation. And then last but certainly not least, if you want to see how 5G actually gets tested, the hardware that goes into making 5G work and making 5G devices work, we have a catalog that looks through some of the different testing tools that go into testing a 5G base station. So that is each day's web page. And in the same vein as that catalog, we thought we would put together a video that has a little bit more depth and kind of shows some tangible 5G measurement environments being made and talk through some of that. So we pulled a 5G video, and we're going to watch that in just a second. And after that 5G video, we have our interview with Kailash, who is one of the leaders here at Keysight in the 5G space. We sit on the 5G spec and consult and have a big influence in how that's played out. So there are a number of people in the company who are very, very knowledgeable and instrumental in making 5G happen. Kailash is one of those people. Let's first, though, take a look at some actual 5G hardware being tested.
Hello. Device manufacturers and test labs face many challenges when certifying 5G devices. These include ensuring access to the mandated test cases, making cost-effective use of test equipment assets, minimizing the time taken to test devices, being able to rapidly detect and resolve issues, and being prepared for future test requirements. Today, we'll take a quick look at Keysight's device acceptance solutions, which are designed to address these challenges. Keysight provides 4 separate solutions to address the device acceptance workflow: Protocol Conformance Toolset, Protocol Carrier Acceptance Toolset, RF-RRM DVT and Conformance Toolset, and RF-RRM Carrier Acceptance Toolset. These solutions all run on a common modular test platform, which scales from a compact benchtop system supporting a large percentage of the test requirements up to a full rack conformance system. Let's take a look at a typical test system configuration. At the heart of the system is the Keysight UXM 5G network emulator, which is uniquely capable of simulating both 5G and LTE base stations simultaneously. Next, we have the Common Interface Unit, which provides power, control, and the local oscillators to the remote radio heads, which you can see on top of the chamber here. The radio heads upconvert the UXM 5G's sub-6 GHz signals to the 5G millimeter wave frequencies between 24 and 43 GHz, which are then radiated over the air to the device under test inside the chamber. In this system, we have a Keysight 2D MPAC chamber, which contains 3 probes to support up to 3 angles of arrival, an LTE link antenna, LED lights, a laser pointer to help align the device, a camera to view what's happening inside the chamber, and a positioner to hold and rotate the device. Finally, we have the Test System PC, which runs the solution software and controls the entire test system. Some of the key benefits of Keysight's device acceptance test solutions include the modularity and scalability of the platform, enabling a single system capable of running conformance, regulatory, and carrier acceptance tests across the protocol, RF-RRM, functional, and performance test domains. The solutions support the highest number of validated 5G test cases from the GCF and PDCRB device certification requirements and the MNO device acceptance requirements. Their ease of use with powerful and flexible software tools that simplify the task of running and debugging test cases. Certify your 5G devices in a timely and cost-efficient manner using Keysight's device acceptance solutions. Thank you for watching.
So I think it's really cool to actually see the hardware that goes into 5G being tested in some of those chambers and devices. That's something that even as working at a company that tests 5G, you don't always get access to go see that. They're only in certain parts of the country. So we brought that in. And of course, we are about to sit down with Kailash Narayanan, who is a 5G leader here at Keysight and in the overall 5G industry. So why don't we jump right into that? And then after that, we will do our test gear drawing. I'm joined today by Kailash Narayanan. Thank you so much for being here, Kailash. He's the president of the Commercial Communications Group here at Keysight and has been intimately involved with 5G from its conception, pretty much. So thank you so much, Kailash, for being here.
Thank you, Daniel.
So the first question is, with 4G, I can stream internet to my phone. I can watch YouTube and whatnot. What was the need for 5G, and what are we trying to achieve with 5G beyond just kind of standard handset stuff?
Yeah, thanks for the question, Daniel. I want to probably go back a few decades when the whole cellular wireless technology got deployed. You started off with 1G. 1G was all about providing connectivity on the go. And it was implemented using analog technologies. And then came 2G, and you were able to now send some data, primarily in the form of SMS text messages. And then you kind of rolled to 3G. You were able to do a little bit of email on the go. And that's how BlackBerry and RIM became very popular. And then 4G expanded upon that by providing access to many users to mobile internet, so mobile e-commerce and social media platforms, et cetera, came into play. So when you look at 5G, combination of Moore's law and improvements in connectivity and digital communication techniques, have really put very powerful devices in consumers' hands. And if you look at people now consuming all kinds of content, video, data, email, for personal use as well as enterprise use, and they're often using their mobile devices as compute platforms as well. So it's become a media platform, it's become your consumption platform, e-commerce platform, and it's also become your enterprise platform for getting work done. So with so much data that gets processed on these devices, clearly the 4G network wasn't going to keep up. And that was one of the fundamental motivations of 5G, was to ensure very good quality of service and quality of experience for not just commercial customers, but also enterprise customers. And that's kind of where it all started. So the focus is not on just providing maybe high data rates to a few users, but it's providing significantly high data rates and quality of service to millions of users, right? So the scale with which 5G tries to accomplish that goal is pretty big, pretty large. So from that perspective, you needed to kind of tackle three main problems. You needed to address the very high data rate requirements because nobody wants to be waiting for minutes for something to download. So one of the key pillars of 5G is this mobile broadband connectivity, extreme mobile broadband connectivity, 10x, 20x 4G rates. Then another pillar was to really help address the use cases that multiple vertical industries kind of bring in. The automotive sector, also industrial sector, requiring a very, very low latency in terms of response times. You know, how quickly information needs to get from one point to another. If you're on a phone call and you're talking to a relative or somebody else at work, you can probably deal with some lag time. But if you're dealing with hundreds and thousands of transactions in the financial market or in an emergency response situation, that requires a completely different latency need. So ultra low latency and reliability is kind of the second pillar of 5G. And finally, 4G was more about smartphones and tablets and how you can put these compute devices on people's hands on the go. But 5G is going to be, a smartphone is probably the dullest application of 5G, right? Even though it's the first application, and that's how it's going to get commercialized. Somebody once told me it's the dullest application of 5G. The real applications are going to be in industrial sectors and in many different verticals like smart utilities, smart energy, smart city, those types of applications, smart factories, smart cities, so on and so forth. So you have pretty much everything communicating wirelessly with every other thing to accomplish big use cases, big business use cases, and macroeconomic use cases. So you potentially could have something going on in an oil market, some sensor gets triggered, and that information kind of propagates back into the back end, changing prices on commodities, for example, on the fly, and reaching the consumer through transactions and so forth. So you see this broad end-to-end connectivity and connectivity between multiple vertical industries to provide real-time information to users in each of those vertical industry so that they have all of the insights on a real-time basis to make the decisions that they need to. So that's sort of the other pillar here, massive machine-to-machine communication, a lot of sensorization of sensorization with an S, E-N-C-O-S-O-R, of these networks to provide real-time insights. So Yeah, absolutely. 5G is needed, for society to progress, and these three pillars. We're continuing to look at enabling these three pillars. We're enabling the workflow of many different customers that are involved in making this real, and that's what we're working on.
So you're saying a bit could flip on a sensor in an oil rig in like Saudi Arabia, and then 5 minutes later my gas price goes a little higher.
That's the dream situation. That's ultra low latency. That is a massive communication across multiple vertical industries, providing real time insights. Now, I mean, for that to occur, not only do you need to have the wireless side of the communications network covered, you also need to have transformation on the wireline side of the network. And when all is said and done, when you have that type of an end-to-end setup, that's the goal.
Interesting. Yeah, when I first started reading about 5G, I thought it was just going to be handsets, but the more I read, the more I see how much is changing. How have R&D organizations and enterprise organizations been changing their approach to this technology as a result of the potential of 5G?
Yeah, that's a good question, and it's honestly it's required a lot of companies, including us, to retool and hire for different skill sets. You've got the physical layer aspects pushing into millimeter wave frequencies. So if you're an RF designer, or if you were an analog or a digital designer, you didn't have to deal with frequencies over 6 gigahertz or maybe 20 gigahertz stops when you were dealing with legacy technologies, including 4G. And with 5G, most of the spectrum availability is in the higher frequencies, the so-called millimeter wave frequency bands, which are all north of 25 gigahertz. You've got the 28 gigahertz band, you have the 39 gigahertz band, and now you have the N262 band, which is pushing north of 49 gigahertz. And these bands require completely different design criteria. So your entire tool chain needs to change, and you now have to hire different skill sets, people that were probably working on satellite and space communications, and people that were working on other millimeter wave technologies and applications are now coming in and working in commercial domains. Yeah, so the push to millimeter wave frequencies is essentially causing this retooling and a requirement for a newer skill set. So millimeter wave design is more complex. I can imagine a 4G wireless technology when you're in the sub 6 gigahertz range. I'm right now surrounded by wireless signals. So these wireless signals below 6 gigahertz they are omnidirectional. So you don't have to be turning in a specific direction to receive the signal. They're present everywhere. So when I hold my phone, I can leave it on the desk, I can hold it close to my ear, whatever, I'm still getting the signal. But millimeter wave frequencies are very, very directional. So direction makes a lot of difference. They have a concentrated beam at a certain angle. And if you just turn a few degrees in a different direction, then it's a matter of it's a very digital experience in terms of whether your connectivity goes through or not. So what this means is antenna design gets pretty complicated. You need to be thinking about beam forming. You need to be thinking about placement of antennas, multiple antennas around your device for proper reception and transmission. So that aspect gets complicated. So not only pushing into millimeter wave frequencies makes your design fundamentally complex, but the directionality aspect makes it even more complicated. The other challenge that millimeter wave frequencies bring, it's all about propagation issues. You're not able to see signal propagation beyond a few feet because it's pretty significantly attenuated, and there's significant propagation loss. So you're dealing with beamforming antennas, high gain antennas. You're looking for more repeaters and access points. And this is also one of those things that will be different in 5G, where you need more of these access points or repeaters, more microcells, more small cells, and not just big macro towers that are covering large distances. So that's complicated. And over-the-air test is another issue because these millimeter wave components are very small and compact. You don't have access to these probing points to measure signals, and the whole 32 antenna element, passive or active, might be laminated onto the chip surface, and they may be an inch by an inch. And you've got multiple probe points there that you may have to check during your design and test cycle, and you can't do that, unlike components in the lower frequency ranges. So what you need to do is now you have to do all of your testing over the air, and that leads to a whole bunch of complexities. You've got to buy different type of test tools. You have to test it inside chambers, and it brings in a completely different dimension to testing and enabling your designs in 5G. So that's all kind of in the millimeter wave and OTA space. When you and it's all in the physical layer aspect. When you move up, the protocol aspect is complicated as well. I talked about how important it is to be very quick and have very low latency, have a very low latency network. And with 5G, the latency is at least 50 times lower than what it is in 4G. 4G, you're probably looking at 50 milliseconds, 40 to 50 milliseconds latency. And on 5G, you're pushing to less than 10 milliseconds, closer to 1 millisecond. And in order to deal with that, I mean, every operation, every protocol operation, whether you're checking for header bits or you're the sender and the receiver is exchanging some information to ensure a good link, and if you're retransmitting something because the receiver said they didn't receive it properly, all of these kinds of protocol and information exchange has to take place extremely fast. And that puts a lot of pressure on both sides of the communication link. Whether you're dealing with the transmit side or the receive side, you have to design everything very tightly, both from a hardware point of view, and any software routines you write have to be very, very efficient. And that introduces a new set of complexities. And finally, I'd say you're dealing with on the wireline side, you're dealing with a convergence aspect that's going on between telecom and IT networks. There's a lot of disaggregation that's going on that has to happen to enable 5G, because ultimately it's all about getting these services, these applications, the data that sit on the cloud, that's on these big data servers, and you're trying to push all of that data onto mobile devices in the wireless network. So you see data centers kind of moving closer and closer to the edge of the network. When I say the edge of the wireline network, and then after that, it needs to do the wireless hop. And as these data centers and the content move towards the edge of the network, there's this blending of things that are IT oriented with things that are telecom oriented, and this paradigm shift, this convergence between IT and telecom, creates a huge it creates a new challenge. Right now, things are getting more software oriented. You're not implementing everything through hardware switches, hardware capabilities. You have a software that does most of the work, and then you're using hardware just for the final transmission side of things. So very powerful software routines running on basic compute platforms to realize network functionality. Security becomes important. It was always important on the IT side, but when you come to the telecom side now, because of software and compute platforms implementing telecom functionality, security becomes important. It's more of a disaggregated architecture. It's not too vertical where one company did everything. Now you've got some software cloud functionality, some network functionality implemented by a certain software provider. Then you have some hardware functionality that's implemented by some contract manufacturer, and then you're putting that together to implement some network functionality, or even in some cases base station functionality. So this kind of disaggregation and convergence of compute and telecom phenomena, it creates a dynamic that forces engineers in the industry to deal with different architectures, more disaggregation, dealing with dynamics that were more prevalent in the IT space. Now you have to kind of think about those in the telecom space, and makes it really interesting challenges for designers. So, I mean, overall, those are probably the fundamental ways companies need to retool, and customers are retooling. Customers that Keysight deals with are retooling, getting ready for millimeter wave workflows and enablement, doing tests using different methodologies like over the air, dealing with this convergence phenomenon that's happening between IT and telecom, and the network architectures that come because of that.
Yeah, it seemed like it's firing kind of on all cylinders, where it's hitting the more IT side of the fence with, the way data is being structured and the move to edge computing techniques. And then in the millimeter wave space, we're doing phased arrays like beamforming and beam steering, where you can't just cable into your antenna array and assume it's good to go, because there's so many more factors that you have to factor in to make your antennas work. And then you can't just test them over a cable, you have to test them in a chamber. And then on the network protocol side of things, we're changing up how packets and slices are structured up, so that you can do, it's not just like a downlink packet and uplink packet, it's a combination of the two, and the transmitter and the receiver have to wait and communicate at the right time to reduce latency. And it's just on every front, it seems like a pretty big overhaul of how we are designing communications.
Yeah, that's exactly right, Daniel. And you brought up question of slicing, and that's also a new concept that 5G is enabling, and it's a critical aspect of 5G. This concept of network slice, which is all about providing a set of network resources. Let me contrast this with 4G, right? In 4G, you had a dedicated network, you had a link, and you provided that set of resources, that dedicated link to your user, to an operator, and things work. A network slice, in contrast, is a set of network resources that that's provided to a certain user. It could be an entire private network, or it could be a set of users, or maybe even one user that you're leasing potentially for a certain period of time to ensure that a certain use case is addressed, and to ensure that a certain quality of service is achieved. So this network slice concept is very dynamic, and it's an end-to-end concept where somebody has access to all of those resources for a certain period of time, and so we can guarantee these SLAs. That's one of the promise of 5G is, if you have an automotive use case, and when years later, when autonomous driving is in vogue, you need to hit certain key performance metrics, and you cannot take chances of network allocation, bandwidth allocation, and other resource allocation. You cannot leave it to a certain algorithm to kind of do it in a very prosaic manner. You need to make sure that certain applications get certain resources during a certain period of time to achieve certain key performance metrics. So, and just having a super good smartphone that can handle all of the data rates is not sufficient to realize the full promise of 5G. It requires a complete transformation of the core network as well.
Yeah, I know if I'm riding in my self-driving car or watching a video, I would much rather my self-driving car work than my video work.
Exactly.
As we start to wrap up, how should people follow up with 5G technology, keep up with what's going on? Are there websites, groups, companies, Twitter account? How do people keep up with the tech?
Yeah, well, I mean, you can certainly follow Keysight. We're focused so much on 5G. We're tracking the market. We have many solutions that target multiple vertical industries. You can go to our website. You can go to our Twitter feeds. That's a good way. And we have many seminars, webinars. We have YouTube videos. We also, for customers, we do boot camps to bring you up to speed on 5G, and also provide you some hands-on time with our solutions, especially if you're involved in designing some of these solutions. I'll just say that 5G is going to be a transformative technology, and it's a big paradigm shift. And it's not something that it is going to touch pretty much everybody who's in the tech industry, because it's touching multiple vertical industries. It's going to impact utilities. It's going to impact finance. It's going to impact transportation and travel. It's going to impact the devices industry. It's going to have an influence on how factories are set up in the future, and so on and so forth. So I'm pretty sure that that's a pretty large slice of the entire macroeconomic landscape. So whether you're directly designing something or you're peripherally associated with something, it's a technology and a paradigm to track, and Keysight would be a great place to start. For anything around basics to all the way something more complicated, especially if you're involved in hands-on design of 5G.
Great. And sometimes we like to wrap these up with a more lighthearted question, so I'll spring one on you. If 5G technology were a vehicle, what vehicle would it be and why?
5G technology. Well, I'd say probably a Bugatti Veyron. It's super fast. It's very dynamic. It's exciting. That's probably where we are right now. But it can also do a lot of different things. So maybe we haven't invented a vehicle that it can exactly match what 5G does, because the super fast aspect is one aspect of it, but like I said, it's got applicability in multiple industries. So it's more like a Bugatti Veyron.
Okay.
Army knife.
Well, thank you so much, Kailash, for your time and your insight. It's been great having you.
Thank you, Daniel. Appreciate it.
So what a pleasure and honor to be able to sit down with Kailash. I hope that was a good educational talk for you. I saw a lot of the chat rolling through during that interview. It seems like people had a lot of good 5G questions. So I'm going to attempt to take on some of the 5G questions that came in chat. I'm also going to be cautious and not misspeak. Since we're live, I usually prefer to run 5G stuff by folks who are a little more acquainted with it, but I know enough to be dangerous, so we're going to give that a go after we do the prize drawings. If you want to see more talks, we've had an interview every day this week. Today's Thursday, we've had 3 already, and we're going to have 7 more during this event. So if you want to see those on the webpage, there's a way to do that. You can scroll down to the bottom of the page and see each of the different days down here. There's also an event calendar, so if you go back to day 3, for example, we can see the interview yesterday with Jay Alexander, also another awesome interview, tons of great feedback and tons of great comments in that live stream yesterday. So it wasn't just an interview, it was also a chat. We had Mike Hoffman. Go see what happened on other days of the event. Go to the bottom of the page, click the previous day. You can kind of scroll through the calendar and see what we have coming and what we've already done. Also, of course, every day in the live stream, we are drawing winners. We have 9 winners per day. Today, we are drawing 5 winners who will get their choice of one of the new Smart Bench Essentials pieces of test gear, DMM function generator, power supply, and DMM. And we'll have a first prize winner who will win their choice of one of these 2 in addition to a couple other different pieces of gear. So we have a 3000T series oscilloscope, and we have an electronic load as one of the choices. I don't remember if that's a first prize or a grand prize winner, though, so I'll have to check that one and clarify in chat. So if the Keysight team could clarify that in chat, that'd be great. The electronic loads are super cool. They just came out in December. There's a 1-channel model and a 2-channel model. I think we're going to do release a video about them tomorrow over on the Keysight Labs YouTube channel, so you can go check that out. And we have 3 winners who will win a U1282A handheld DMM. So today's winners are polling now, and we already drew 4 of the Smart Bench Essentials winners, and we forgot to put it at the end of the 5G video. That's lower down in the video, so my apologies for that. If you watched it on YouTube, we put it in the chat, but also those winners were Hans Deuce, Philip Sebastian Vogt, kind of like the author, that's cool, Corey Smith and Rory McFeely, and the other winner, Smart Bench Essentials winner today is Kodovniech Vitali, congratulations to you. And our U1282A winners are Jacob Francis Burnett, Matthew Sparby, and Marcus Neiman. And the first prize, I know we didn't announce it right away yesterday, my apologies for that, Joshua Lowe. So congratulations to all of our winners. In chat, we're also putting a link to the winners list, so we'll get those updated as soon as we can. We draw these very, very close or during the live streams so that people have a chance to be entered in the drawing. Any new folks can get entered in that day's drawing. We'll also shoot you an email pretty soon, like in the next 48 hours or so. It might be Monday, we'll see. So congratulations to those winners. We're super excited. And thank you all for being here and participating in this event. It's one of the highlights of my year for sure. I love interacting and seeing you all in chat, and throughout the year we're around. So make sure to hit that Get Updates button on the webpage so we can keep this thing going. This is going so well. Everyone seems to be having a good time, so we're going to try and keep some of this going throughout the year as well. So it's now time to take some questions in chat. One of the questions that we keep getting is, where do I go find Smart Bench Essentials? How do I buy them on the website? The team is putting some links in chat. We'll also put some in a blog post, but if you go to those web pages, there's a Get a Quote button. If you go to those web pages on keysight.com, there's a Get a Quote button, and that button can vary based on what country you live in. Every country in the world has kind of a different set of regulations, and it's complicated and varies by region. So there's not one set answer of go click this button and here's how it works. It's very regional, so you can go check that out. You can also find a local distributor for the Smart Bench Essentials by going to keysight.com/find/distributor and filter by country, and you can find your local Keysight authorized distributors by your country. So that is another place to go to find stuff. Another question we get is, are the drawings random? How are we picking names? We never go into too much detail about the specifics of our drawing mechanism, but it's been reviewed by me, by our legal team, by our security teams to make sure that it is sufficiently random. It's actually random and secure, and that no one else is gaming the system. We've seen a couple bots try to game the system this year, and we're just, those people don't win. Don't shoot a bunch of emails panicking. We can look and see the history of what people are doing and tell kind of how much. We do some IT forensics and see how if people are actually trying to cheat or if it's honest, like I signed up twice and whatever. We can kind of see that. Okay, enough of the business. Let's get into some of the 5G questions. Someone asked, is 4G going away or is it just 5G? So that's a good question. And there's another question about, can 5G penetrate like walls and tunnels and buildings? How good are 5G signals at getting through that? 5G signals don't really go through like walls or glass or tunnels very well because of the high frequency. There's more about that in the video at the bottom of this page that goes into millimeter wave frequencies. But essentially, and I think Kailash probably touched on this a little bit, is there's a handoff and a trade-off and a partnership between 4G and 5G to make sure that we can get full coverage even like in our studio. If I walk out of the room, I can go to the window and get 5G, but right here it's often just 4G. We'd have to get an actual 5G node in this building for me to get 5G just because of the number of walls. So there's a combination and a partnership between 4G and 5G that has to happen to make a seamless experience for us, the users, because I want those internet data streams into my smartphone. And like Kailash said, my favorite quote from that interview is, the dullest application of 5G is a smartphone, which really, when he said that, kind of got some wheels turning in my head as well. So I'm really excited to see where 5G goes in the future. What else? What else? We had lots of questions. I'm gonna just scroll through and make sure. Have we thought about making a how it's made style walkthrough about what it takes to make a scope? We have recorded my video guy's giving me wide eyes over here. We actually recorded a walkthrough of our factory and our environmental testing chambers and stuff downstairs. So that's like in the back of our minds to put together and edit. If you want that, let us know in chat, and I will send that chat log to my video editor who has his head in his hands because he knows he has to try and edit that video now. I think it'd be super fun. We do have, it wouldn't be we do some proprietary stuff as well, so there's some things that we probably shouldn't show, but it'd be pretty cool. There's a whole factory floor below this floor that we build a lot of our high-end probes here. We do some low-volume chips and things like that too. It's pretty cool. That's a good question. It comes up a lot. What is the impact of 5G on the health of human beings, animals, and the environment? I will touch on this. I know it's a touchy subject. 5G and just like LTE 4G signals are, it's non-ionizing radiation, so it shouldn't impact the cells at all. The signal path does a great teardown and explanation of are 5G signals harmful? I would absolutely recommend you go check out that video. Signal path 5G, if you put it in YouTube, it'll show up. He talks through that. He's PhD electrical engineering, like big brain, once in a generation kind of guy doing a YouTube channel about stuff like this. It's amazing, so go check it out. But the answer is no, it doesn't. It's non-ionizing. We know, so there's some questions about frequency range 1 and frequency range 2. 5G is rolling out now in frequency range 1, which is like sub 6-ish gigahertz, maybe sub 7 gigahertz. And then frequency range 2 gets into those millimeter wave frequencies. And it's almost a different set of hardware and technologies and test capabilities that go into these. So it's pretty complicated. We cover some of that in the video that's at the bottom of this page, and we talk about that a little bit with Kailash. We also have another 5G interview queued up for later in this event, so make sure you're tuned in for that, and we talk a little bit more about both that and the network side, because once the signal hits an antenna, the whole antenna radio access network, or Open RAN with 5G, is a whole other animal that we haven't really even touched on yet, so I'm excited. There's more 5G stuff coming if you like that. What about 5G signals and weather? Yeah, oxygen and water both impact the propagation of signals at certain frequencies. So it does, like a rainy day, your 5G signal won't be as good. It's just going to be the fact of it. And that's where having 4G, having 5G working hand in hand, having frequency range 1, frequency range 2 working hand in hand, and splitting up bandwidth parts into different parts of the spectrum will become really important. We'll do a couple more questions, and then we'll keep it shorter today because I don't want to get myself in trouble and misspeak on 5G. Not that I'd be in trouble, I just don't want to steer you wrong. Someone asked about power safety limits. I don't know. I'd have to look at the spec, but it is, it's all FCC measured, and depending on your country, not the USA has the FCC, but like the ETS in Europe and all that. There's been a ton of research into this. It's non-ionizing at these powers. Shahriar on Signal Path also, he did an interview on the EEV blog and Chris Gamel's podcast called The Amp Hour and talks a little bit about that as well. And he talks about it in his video, like if you took a phased array antenna and maybe stuck your hand right on it, then it might heat up, but don't stick your face in front of a cell tower antenna. You don't want to do that now anyway. It just seems like a bad idea. Okay, no more. We're not going to do any more health questions. This is a good question. Isn't the difference between, so someone's asking about the difference between DBM and DB. So we talked about this a little bit in the FieldFox video on Tuesday where we had a key and we showed that you could actually increase the signal range of your key by holding it up to your head or your face. Or we built a reflector and did some other tests with a coffee cup, not this one because it's not metal. And in that video, I say DBM is a ratio, or DB is a ratio, DBM is a power. And someone's asking for some clarification on that. DBM is with respect to milliwatts. So it's also interchangeably, someone said this in comments, DBM is also DBMW or DBM milliwatts. So that's power with respect to 1 milliwatt, whereas DB is just the difference between two different power levels. So DBM is power because we have that baseline 1 milliwatt of power thing that we're comparing it to, whereas DB is just like an amplifier has this much dB based on what you put in and what you get out. So there's no reference back to actual power. So we got a lot of comments saying they would like a video on DB versus DBM. I think we're gonna make that happen in the future. So make sure you are subscribed to the Keysight Labs YouTube channel and you're following along with this event. I don't know if it will be here as part of this event or as part of the follow-up. We'll see. Just kind of depends on how scripting and working goes because I want to make sure to get a good video out for you all. A couple more questions. Someone asking about the beamforming aspect of 5G, but with higher path loss, does that make it more efficient than 4G's omnidirectional signal? I don't know the explicit answer for sure. I think the answer is probably it depends. I said down low in the other video that 4G radiation just kind of sprays out kind of like a big donut around the base station, where 5G does directional signals at your phone. It's definitely more efficient in that you have all your signal concentrated in that space, but path loss really depends on distance. We use that power loss calculator in the video, which is for free online. So if you want to go play around with values, you can change frequencies, ranges, antenna gains, that sort of thing. That's a pretty cool calculator to play around with if you want to get a feel for it. So the answer is it depends because there's a lot of variables. It's not just 5G is more efficient than 4G. It really depends on the scenario and the situation for both of them. A couple more questions. What about the infrastructure required to achieve 5G? Are there any cities fully upgraded? I don't know if there's cities fully upgraded. There have been some really cool technological advances where you can actually update 4G to a 5G network just with software updates at the base station and at the server side. So it really depends on the application of 5G. It's designed to be super flexible in terms of what the control unit and the distributed unit and the end user all are doing. So there's not one answer of this is how you make it 5G. You have to really look at the application and the use model and decide what sort of radio heads are you using, how much are you putting on the server side, or the deeper into the stack, how much are you putting out in the field at a base station. So there's a lot of factors there as well. If you want to learn more about 5G, the 5G courses linked, the Keysight University free courses at the bottom of this page, they're really good. We've spent a lot of time trying to distill these concepts into manageable chunks of information. It's still a lot of information, but we put a lot of blood, sweat, and tears into these. So I think that if you want to keep learning, because I'm seeing a lot of questions in chat, that is a great technical resource for you. There might also be a 5G textbook download. I don't have my textbook here, unfortunately. I believe there's a download for that. I will go looking for it, and we'll put a link on this page for that. And that's a good place to read through and learn. It talks about 5G testing and some of the 5G fundamentals as well. There's a PDF. You probably have to sign in to get it somewhere, but we'll check for that link shortly and drop it on the page. I'll also put it up on my Twitter at Daniel Bogdanoff. So we're going to call it a day. We'll be back here tomorrow. We're going to look at the electronic load. We're going to do another live stream with Q&A. I am super excited. And we have an interview tomorrow with Liz Rooch about quantum electronics and quantum computing. I know it sounds, I've seen in comments, people are like, quantum computing's fake. It's not fake. We have video clips of actual quantum computer and control systems in this interview. So get ready. It's going to be awesome. I'll see you right back here at 10 a.m. Mountain Daylight Time? I don't remember. Mountain Time tomorrow. Again, thank you so much for joining me, and I'll see you tomorrow.